So guys, so it's just very again understand. So it's a new dimension. So don't mind my happiness anyway. So if you are just coming across this video for the first time, don't forget to click on the subscribe button. Yeah, click it twice. The second time you click it, then you select all. And if you go on my YouTube channel, I mean my TikTok page, the same thing. Yeah, I just opened the TikTok. Alright, so today we shall be looking at galvanometer conversion. So on PHS 001 jam bytes and why students you are free to learn from it, but particularly for jam byte. So you know what galvanometer is, we've discussed that earlier before now. So but the main part of it is what you are going to be considering is how do we convert a galvanometer to ammeter. Over time this kind of question comes out in your UTME question, so you get. So in case you have an option or question that has to do with how you convert a galvanometer to ammeter, so it's simply that a galvanometer can be converted to an ammeter by connecting a low resistance shunt in parallel with the galvanometer. And I want you to know something. The other name for a galvanometer is called what? MCM. What's the full meaning of MCM? We call it moving coil meter. Sure you get. The other name for galvanometer is what? Moving coil meter. So study this very well and understand it. And suppose I have a picture like this, for instance. We are moving to calculation now. Quick one. Suppose we are having a picture like this now. You see this deflection here. Beneath this deflection here, we have our small r. And what's our small r? Galvanometer resistance. Sure you get. So this I, you see the current is moving. Don't forget, current moves from where? Is it from positive to negative or negative to positive? You can drop the answer in the comment section below. I discussed that in the last class. So this ID represents the current flowing through the galvanometer at full scale deflection. So that's ID. We have the parameters we have in these diagrams. We have IG, we have I. I just want you to know that we have R, we have the small r, we have ID, we have an I, we have the big R, we have the small r. You understand? So this one is the current of the what? Of the galvanometer, or current flowing to the galvanometer at full scale. And this ordinary I is ammeter reading of the converted galvanometer. And this big R is called shunt resistance. And this small r is called galvanometer resistance. Altogether, we have two types of R. The big R is the shunt, and the small r is the galvanometer resistance. And the IG is the current flowing through the galvanometer, and the I is this. Then whenever we have something like I minus IG represents the current flowing through shunts, because in case you have to calculate the current flowing through shunts, current flowing through shunts is always I minus IG, because in this I of the ammeter reading is always greater than the IG, so which tends to give us I minus IG. Take note of this very carefully. So all these parameters are parameters you studied very well. Potential difference across shunts is given by shunt current times shunt resistance. Shunt current is I minus I. Shunt current is the same thing as current flowing through shunt. Shunt current is the same thing as current flowing through shunt. So shunt current is I minus IG. And resistance shunts, shunt resistance is capital letter R. So let us solve the question. I'm going to be solving a question, but before then, so take note of this formula very well. Shunt resistance is equals to what? Is equals to current through galvanometer times galvanometer resistance over shunt current. So take note of that very clearly. The shunt is down, and the galvanometer, whatever is of everything you have to do with galvanometer, shunt galvanometer, and current through galvanometer, and the remaining one down is shunt current. So now from this question, I decided the galvanometer of resistance of what? Resistance 5.0. So the galvanometer resistance is given by what? It's given as that small letter R. So our small letter R is 5.0 ohm. Okay, these are your parameters first. As a full scale deflection of current of 100, okay, as 100 meter ampere. So current and ammeter current of whatever at full deflection, that's then you have to convert it. That is 100 multiplied by 10 raised to power minus 3 milliampere, right? And I told you in the physical class that mainly is 10 raised to power minus 3, so you understand that's 1 times 10 raised to power what? That should be 2 minus 3 indices, that will be minus 1, which is the same thing as 0.1 ampere. Okay, you're correct about that. So what else do we have? We have, how would each range be extended to 1.0 ampere? So our I, okay, this is Ig, and our high is 1.0 ampere. Sorry, this is the current through the galvanometer. This is the ampere current. Okay, so now we're moving on. We have, by placing whatever. So at the end of the day, it is very obvious that we are looking for the shunt resistance. So now we can solve our problem. So that will be R to be equals to Ig multiplied by R over I minus Ig. Okay, so what do we have here? Our Ig is 0.1 multiplied by our R is 5 divided by 1 minus is 0.1. So what do we have later on? We have 0.5 divided by 0.9, then that's 5 over 9. Alright, so now see a resistance in, where do we have a 5 over 9 here? So this is it. It's very clear that is our answer. So our answer is a resistance. I'm placing a resistance of what? Of 5 over 9 ohm. Anything resistance is ohm for the units in what? In parallel. In parallel. So that's our answer. So we solve another question. This will be the second question. Okay, this is the second. So we have this question now. We want to look into it and solve it. First of all, they gave us that we can only have a resistance of what? A resistance. So the resistance of the galvanometer is small letter is 5 ohms, right? This is alright. So by using a short wire of the resistance 0.05, so shunt resistance is 0.05. Okay, the galvanometer could be converted to an ammeter capable of reading. So our I is 2A. What's the current to the galvanometer? So we are finding Ig. So now finding Ig, but before then we can still draw a diagram. We have our deflection. Deflection can be like this. We can have this guy. These are our shunts. Alright. I'll do your diagram like this. So it's coming like this. Don't forget that this side is I minus Ig. What is I minus Ig? That is 2 minus Ig. And here we have 2A. And here we have 0.0. This shunts resistance. So 0.05 ohm. This one, R small letter R here. We get R here. This one is the resistance of the galvanometer. That's 5 ohm. Okay, don't stress like that. So now, do you remember that we still the same formula we are using? That's our resistance shunt is equals to Ig times R over I minus Ig. Are we together? So which implies that we are having I minus Ig. R equals to our R we've gotten it already is 0.05 is equals to Ig times 5 divided by 2 minus Ig. So by the time we multiply this guy, let's expand. So (0.1) minus 0.05 Ig equals to 1 equals to this. So that's Okay, so this will be 5 plus like 5.05 ig 0.1, right? At the end of the day, you're having ig to be equals to 0.0198, which is the same thing as 2.0 times 10 raised to power minus 2 ampere. Okay, so at the end of the day, what do we have? 0.00, okay. Okay, so do you understand? So we have is 2.0 times 10 power minus 2, which is the same thing as 20 milliampere. Yeah, 20 milliampere. Because here 10 minus, you know, this one will be 2 times 10 is power 1. So 1 minus 3. So you got that. So that's all about this. So try to understand the concept about it.